Okay, welcome to this Code Lab session of the talk we had before. We will quickly take a look into how we do virtual reality in Android. Before I was talking about Daydream, right now I'm talking about Cardboard. And I want to take a look into how we can do some similar things as in Unity, but just using OpenGL and the basics there. So again, just to get like maybe me to know you a bit better. Like maybe we can go through the lines and just like everybody tells a bit about themselves and what their experiences are, so that I can know how deep and how we structure it. So do you want to start over there?
Sure. I'm Drew. I don't really have any experience with VR, with Android for sure, for like 4 years, but haven't dabbled in the VR much. So just coming to learn whenever I can.
Same. Okay.
Yeah, pretty much the same.
Okay.
Similar thing, been an Android developer for about a year.
Okay.
Embedded space.
Nice.
Learn more about virtual reality.
Oh, that's cool. Okay, let's see. What about you?
I'm the same.
Okay.
One deep in the same bucket.
I used Unity before, but that's about it.
Okay. So you're the last.
I've been an Android developer for 3 years, and I added a VR view to our app.
Oh, okay.
Trying to figure out how to build a room experience, I guess, similar to what Netflix did recently.
So what is your app like? Is it a video app or?
I work on a baseball app.
Okay.
So
So it's about playing baseball in VR? No, that would be too easy.
something like that.
Seriously, nice.
Watch videos and then maybe show some data about the game.
Okay. Oh, that's cool. So like you are then one of the more experienced ones in this room. So I don't know, do you feel like sharing your experience so far, or like is it like difficult or?
So my experience with Unity is, I don't have a lot of experience with Unity. So I first tried building something in OpenGL using the Android libraries for that.
Yeah.
I had a hard time with that. But my first experience was I was trying to create a photosphere on my own without using the VR view because I was having some difficulty playing HLS video.
Yeah.
So I built a cube and then I projected a video.
Okay. Nice.
Surface view on top of that. But that was hard to do, so that's why I'm trying to learn about Unity also.
Yeah. Ah, okay, that sounds nice. So, yeah, what I would like to go through is like just the way I did it for an app we did at work. So again, we are a content management system, and I just wanted to get like the 3D objects in our content management to be displayed onto like cardboard or something. So how I started is I took a look into the existing cardboard sample. And the cardboard sample is like the treasure hunt app, because I wanted to do it in Android, because I need the library in Java, because we don't have a .NET or a C# library yet. And this sample of the treasure hunt was just, it was in the main activity, everything got handled. And that's good for a sample, let's put it like this. But if you want to like go closer to a production app, it doesn't work. I'm running through the slides. I'm sorry for the viewers, but why I'm doing this is because this is based on a talk I gave in Romania, and I just wanted to see like if we can develop a good system like which can be productive. So my idea there is, okay, we know how like normally it works. Like you have an MVP model which you like separate concerns in order to like make it run. And my idea was like, okay, maybe we can have a model view, presenter, and a renderer. So like that we combine the already existing things and let it run on top with OpenGL. So I'm assuming everybody has a cardboard or know what a cardboard is. If not, I have still some left. If you want some, just come forward and take them. Also, yeah, I'm not going to go through like the details that it's rendering the screen in a separate way. This would be where you can get the current setup, and this is the base what I took a look at. This is the sample treasure app. Yeah, so you find the cube, and you rotate the screen to find the cube, and then you hit the button, and then you can find the next cube. So far, so simple. And this was the general layout. Yeah, I would more propose on like something like this. The idea there is that the presenter handles the view, and the view connects to a renderer. and the renderer does like all the interaction with OpenGL. Whereas the interactor, for instance, can be like serving the 3D assets from a file system or from the cloud or from a management system or whatever. Because like also, as we know, as Android developers, right, this is like better testable. Or actually, it is testable. The one before was essentially not. And like, since this is a code lab, I need your interaction, right? So I see you nodding, and I really like this one. But I don't know about the other ones yet. So as far as I understood, like you would like to more how to do it and not do it, right? Okay, so then I just kind of continue on this way and not like really code something live because I also don't have Android Studio on this one. So it's a great compromise. So if we go for like, again, the whole interactor model, the MVP model, I would like say, let's take a look into this kind of interface for an interactor. So this interactor listens to our database and see like, okay, I have actually received a model, please view, update your view or whatever you need to do. Also, this interactor has a method which says like, hey, please request all the things you can get from the model so far. So like, I want to say basic. The same thing for the presenter, right? The presenter implements the interactor listener, and whenever it receives a model from the interactor, it just like positions the object next to the other ones it already got. So in the end, we will get a list of objects showing up. What it does, it adds also calls the view. So like, hey, I have actually now received a model. Please add this one to your list of to be displayed models. And then inside the main activity, which is in my case also the view, I will create the renderer. The renderer is there for actually like displaying the model in 3D using OpenGL. Whom have I lost so far? So that means either all or none. So I'm not sure.
Makes sense to me.
Make sense? Okay, cool. Again, just like trying to understand what we can do together here. Also, when I create this view, I have to set up like all the interactions between each other. So I have to create the renderer, the presenter, and actually bind the presenter and the renderer together so that they know about each other. What I also need to do in this case is, because I wanted to use the default way, I have to, if you go back from the main activity, I have to extend the cardboard activity. The cardboard activity already takes the burden of creating an OpenGL surface and context. So I can use after this one immediately OpenGL commands, which is quite nice because, again, I don't need to like worry about surfaces or anything. And it also provides me with something like onSurfaceCreated. Okay, this is my handler where I could like just continue creating things on the OpenGL or for OpenGL. But it also gives me something like onDrawEye. So the last method over there gives me an eye. And inside this eye, I know, okay, this is the left eye or this is the right eye because they have the matrices. Like they have the position and the rotation for each eye. So I also don't need to worry about generating those because they will come from the framework. And the only thing I need to do is like actually tell the renderer, hey, this is your perspective matrix for this eye. Everything gets rendered, and then the cardboard SDK takes care of like, this is now the left part of the screen or the right part of the screen, which helps me with my renderer because it's for both eyes always the same code. So I can call the renderer.render method down below. Perspective is the perspective matrix. So you can think about it, it's the configuration of your camera. So like, how far is the opening angle? Where is it in space? How is it rotated? And all of those things combined into one. So I keep talking about the render, so let's go into like the deep OpenGL things, right? So what I do is, like, once the surface gets created, I create the floor and the ceiling. This is essential for VR apps because without the floor or ceiling, you would just see randomly floating objects, and you don't have something which your eye can reside on. So if you rotate, you always need to like say, okay, I'm rotating now or not, because otherwise your brain would not know what's going on, and you will get this motion sickness problem again, which we are always trying to avoid. So for my basic apps, I always have like some kind of grid layer on below. If you feel more creative, like you can also add like, I don't know, a landscape or something. But most of the time I'm not feeling creative because, sorry, I'm a programmer. But this is also recommended by Google. So if you are if you are starting with a new app, think about how you can create the most richest environment for your users. So if you have seen the Daydream demonstrations on the I/O, there were always some birds flying around and something which you can focus on playfully, which gives the user more of a benefit of like actually getting into VR because they see something nice they actually want to see, and you can also integrate it with your app and like just have something playful going on. But except for this overall design idea, let's go back to the renderer. Once we added the floor and the ceiling, we get called every once a frame. Hey, come on in, it's all fine. Once per frame, we get called the prepare. The prepare is setting up everything we need for OpenGL. So like, do we want to have depth tests? Like, do we want to know if, like, do we want to display things how they are in order of the depths of the set? So do we want to do depth sorting? It's a different thing. So the depth test just determines that when there is something in front, it does not get, sorry, I'm missing in words right now, intercepted with things behind it. Also, you can enable the blend mode here. So like if you have transparency on your textures or something, then you would need this blend mode set onto your GL state machine. Also, there are more things you are normally setting up. So like you're setting up which textures to be enabled and so on. The other thing which I quickly glanced over is the add pending models. So since OpenGL is always running on a different thread, especially the rendering, we have to make sure that if we want to do OpenGL calls, we have to be on the GL rendering thread. So that's why on the prepare call, I actually take a look into, okay, what are the models I want to add for the next frame? So let's say in between two frames, I got a new model from the backend, right? It just says like, hey, there's something new available, please add me to your scene. I use this call in order to be on the right frame and then generate the textures and the frame buffers I need inside, again, the right thread module.
Which method were you saying you would use to do that? Which call? It would call the renderer, so the model would call the filter through the presenter and then the view and then the renderer. Is that what you were saying?
So I'm saying, like, in order to make sure that it's running on the right thread, you need to go for the cardboard activities callbacks. So like if you extend from the cardboard activity, there are this unframe ready, I want to say it's the name of the method. I'm not entirely sure about this one. And this one will ensure that it's like on the right rendering thread. Because otherwise you will get this like, okay, if you try to access something from the off thread, then you will crash. So. Drinking, sorry. And now we get to the heavy-duty method of the renderer, which is render. Render means, okay, I actually want to display all of the objects onto my OpenGL scene. So also, as you can tell, we have two for loops, right? So we have one for loop which goes through background models and one who goes through foreground models. The idea is that you separate models with transparency from the models who do not have transparency. Why? Because if you're rendering transparent models and there is something behind it, but you render the one behind it after the transparent model, you will not see transparency. Okay, I don't know if I can explain this better, but because we enabled the depth test before and you want to render something in behind the transparent model after the transparent model got rendered. You will not see it through because the depth test realizes like, hey, okay, the transparent object is already in front of it. So it will never render something in behind it, but you would be needing this one because it is transparent. So that's why you render everything which is non-transparent first, and then transparent things afterwards.
Which classes here are your classes when it comes to standard classes? Like, is model something that you've written or is it provided?
The model is something I've written. So like this is storing the vertices, like the 3D points, and the faces which are connecting the 3D points. So after let's take a look into like how the actual rendering of the model works, which I can't. Sorry. So sorry. So I can not show it easily right now how this render model actually works because it will be like on a different laptop. So, but sorry.
You have GitHub up there. You can click in that class and make it.
I could. Do we have?
I don't know.
I mean, let's find out. That's like, right? That's the beautiful thing about having a code lab, that it's interactive. So let's find out if we can. So it is hosted on Contentful Cardboard. I hoped. Okay, it's actually not here because we have like two repositories. We have one which is the official supported one, and then we have a lab where we just publish things we are interested in finding out. It's not lab, it's labs. So now if I go for cardboard, we have this one. So this is the sample I'm going through, right? And if we, can you see it or should I make it somehow bigger? Sorry, I know how to Mac. That was like my happiness right now. So let's find out. So this is like the folder structure, and we want to probably go into here and go into the cardboard renderer. So render model. So this was the method I was talking about before, right? Again, is it too small or yeah? Ooh. No, I don't think so. Maybe. Plenty or okay. So, what does render model do, right? So let's think about what a material is, right? So except for the 3D data I was mentioning before with the vertices, the corner points, and the faces, we also have something like a material, which is the shader, which is the texture you are putting on top of the 3D information. In order to like actually like, okay, so the model contains also the material. So and in order to apply the material on top of it, you have to create the combination of the model matrix, of the model view matrix, and the perspective matrix. This is now going a bit too deep into like computer graphics theorems. So maybe we can talk about it afterwards, but I'm also not 100% certain there. What's important here to know is like if you are setting up the material, you have to provide all of those three matrices because a material is like defining how it looks actually like. So once you have set up the material for like rendering the textures or something, you have to tell OpenGL, okay, where's the data coming from? What I'm actually like about to be displaying. So in this case, I tell it. Sorry, I did something. I'm sorry. Again, I don't know how to make. I try 2 fingers. Okay, I'm sorry for that one. Let's just click here again. Never touch the pad again. So yeah, I wanted to scroll. And that was That was the mistake. I still don't know how I did it, but anyway. So I just open it again and never touch the touchboard again. I'm sorry for this one. So I will not scroll to the end of this line, but what it says, it like defines, okay, I have like one big blob on the GPU, and I tell it, okay, which parts are now actually the vertices, like the corner points, and which parts are the faces. So when I add the model, we can probably also take a look afterwards on it. I will create this big blob for every model, saying, okay, in this binary space on your GPU memory, this will be the vertices, like the corner points, and this will be the faces, and this will be the textures for every vertex, and then we also have probably something like an index list. So what I'm telling with GL vertex attribute pointer is, okay, those are the positions. This is where you start reading your positions from. GL vertex attribute pointer with the parameter somewhere down below where I don't want to scroll to right now. You will see like this is actually the pointer pointing to the positions of the normals and so on. And so after I've determined like, okay, where are like my starting points in the whole blob on my GPU, I just tell it, okay, now please draw an amount of triangles. And this will end up and then like just going through like all of the parameters we set up and actually draw the model we got beforehand. Yeah. I don't know, and let's go into the, if you remember the add pending models, this was this, okay, I get the model from my CPU memory, I am now on the GPU thread because I'm in the on prepare call, and now I want to transmit those over to the GPU memory. And this is what the add pending models is supposed to do. So first of all, I create from the prototype model, which is the one we are using on the CPU. Sorry, a new GPU model, which I just called model. The type is called model, and in this case, because I'm actually displaying a product, sorry, this model is a product in the variable name here. In order to create this model, I give this a name, which is coming from somewhere, and I give it the mesh. The mesh in this case will be just a list of float buffers on the CPU memory containing like all the corner points, the texture coordinates and everything. I also tell it like that you should use a texture material, which we can probably also take a look in a bit, saying, okay, if you are like rendering this model, please use a texture by setting up the shaders the right way. Next to like the model parameters, I also need to say, okay, please move this object in 3D space to this position and scale it just a bit smaller because I realized in the end, like this is just showing up too big on my screen. So this is the foreground model, right? So this is directly the thing coming from, let's say, the back end. But what okay, yeah, so sorry. And additionally to this product, I also wanted to add a description. And this description is essentially just a rectangular area, but I have used Android views for it. So what I like about this one here is that if you have a view created, you can tell it to actually get me a bitmap of this view. And then I can use this bitmap on a texture and actually don't have to worry about rendering like text or images or something because it's all the Android layouting mechanisms which are working in place here. Which is, if you are doing OpenGL, it's like always quite fun to like do texts because it's not easy, right? Especially if you are like not in a Latin speaking or a Latin written country, you don't want to have bitmap textures or anything. So it's always good to have this kind of like ruled out by some system. And in this case, I'm using again the Android rendering system. And so I add this product, and then I also add the sign, which is telling me some more things about, like, I don't know, the model I'm displaying. So, for instance, the price or what the name of it actually is. Yeah. And in this line, I'll also scale it a bit more, that it's like just a bit bigger than the model coming in. Okay.
texture material, is that what you were saying was in the view, part of the Android view? Or which part of this was tied to the view?
Yeah, so like we have from the proto model, like the thing which is on the CPU, we have the sign texture. So let's take a look how the sign texture is generated. So, I think it was in here. It was not, because those are just the interfaces I define. I actually am starting to look for it.
So just search the repository at the top for the class name.
That would imply that I know the class name.
Oh,
So this looks quite. No, I'm sorry for that. I think I were here before. Ah, that's where I wanted to be. So we have like not just MVP in this one, but we're also using RxJava. So, and in order to like set up the queue, I created a new function who maps from a product to a proto model. So the product is the direct thing coming from the backend saying like, okay, please use this asset, this is the name, and we have like this kind of price, this is the rating. But the actual magic happens when I call this function, right? So, because I want to now render the sign, right? So I first create the bitmap. I want to store the view in later on. I create a canvas based on this view. And then I just like say, okay, I want to create like this amount of pixels by this amount of pixels by using the measure spec. The product display is my custom view, which I just inflate based on whatever I want, and then inside I'll update this custom view with the product. So maybe we can also take a look now that I know how this one is called into the product display, but it will be a custom view with like a text view inside and like some specific layout that, yeah, we see some things on this layout. The interesting part is this part down here. Because I first say, okay, I now have this custom view. I want to measure it based on the measure specs. So like I just want to have it like in 256 by 256. I lay it out and then I draw it on the canvas. And then since I have set up the canvas using the bitmap, I can just like give this bitmap back and then use it as a texture later on. So for me, this was like one of the learnings from like doing this thing that like I can just use the layout. And like also, if I would have Android Studio on here, I can just use the layouting directly and then change the contents of the texture without really needing to know how to do it.
So if you want to use layout, basically you just get it to lay out onto the canvas, use the canvas, and you get the bitmap from that.
Yeah.
And then the bitmap is what's used on the OpenGL.
Yeah, exactly. That's the right way. Because then I can also like use images and whatnot, right? So like I can have an image on inside of my bitmap, and I could potentially do anything I think which like the layouting system in Android supports, like sliders, stars, whatever ratings.
Do you have a video to show what you built?
Talk
about like where the product is
yes,
to show it.
yes. This was my awesome slides before. Hey, what? Ooh, new shortcut. I'm sorry. So again, this will be a bit ugly, but this is my talk, and I'm talking about this thing here. So, sorry. Yes, you're right. I should have started with this one. You see, like on this side, this is what I'm actually rendering. Like one of those things is coming down from wherever. This is the model I'm rendering, and like from here to there, this is the big texture. I have a bit of spacing in here because this will be the transparent area. Because I just wanted to have like one big quad and don't really want to worry about like what's going on in this inside. As you, I don't know, probably can also see like here you see stars and different texts and everything, like also differently styled and anything. Also, there's a little line underneath it. So again, it's like just general Android layouting. And yeah, so like the more items I get, the more I add just underneath it. And I also added a slight rotation on all of them so that like there's just something happening. So yeah, and once we are through all of this, like once the rendering is complete, one of these items gets displayed. So like the two textures are on top of each other. You can also tell that like the cat, for instance, has a texture, and this is what the, like again, the material is like. I'm supposed to talk to 50, right? Or 40, I think. I'm sorry. So because I already see like people packing in, maybe we should stop it here, or should we go through it? It's 40, then my watch is bad. I'm sorry for that one. Okay, so yeah, that's also what my watch is telling. So like I wanted to open for like some general more questions and answers, or like also more ideation. Like, do you think that MVP and OpenGL works together? How, like, is this something you would be able to work on right now, or what is missing there for you?
I was working with OpenGL, I was having a hard time figuring this out, but like using what you described with MVPR makes things a lot clearer, I think.
Okay.
Also better for debugging.
Yeah. Oh, that's good to know. That not I'm just the only one liking this one.
Yeah, I didn't even think about using MVP. Because I was just playing around with it, but
Yeah.
pretty cool.
Yeah, because like also with the rendering, right? You can just like shut out the rendering completely and just do something completely without OpenGL. Okay.
Your talk before, you basically said, oh, like here's how you use Unity and you can import everything. I
Yeah.
don't know much about this. It seems like you're saying, well, this is the alternative to using Unity. So how do you choose between them and why?
This is like one of two alternatives to Unity. So if you want to do it on Android and Java, you could do it by hand, which is essentially what I did here, or use third-party libraries like, yeah, lightweight OpenGL, I think, is like one Java app, one Java engine running on OpenGL, and you could also combine it the same way. So like whenever I call it like on the draw I do directly OpenGL commands. And there you would then hook up the third-party library rendering for you. So this would be like the second way if you don't want to do it by hand. In order to find out which of the three ways you should go for is like essentially depending on A, your expertise. Like, do you feel comfortable on writing OpenGL code yourself? B, like, are there libraries which are doing the same thing for you already? And how much time do you have? So if you want to like just have something simple, looking nice, then I would probably take a look into Unity, honestly. Even though it might be not terribly easy to integrate it with your already existing app. I think we talked about this on the way here. But if you separate it into like a different app or a different library which you can call from each other, I think this might be the easiest way. Because I see a lot of people being like scared of OpenGL for like, I can see why. I like to play around with this kind of technology, even if I'm not 100% understanding everything. But yeah, you also invest a lot of time there.
What kind of things go wrong when using OpenGL? I've never written it.
What kind of things can go wrong if I'm using
Device
OpenGL?
dependent, you know,
It is device dependent too. So like,
Do you have to test on a lot of different
sorry?
devices? Do you have to test on lots of different devices? Like, what are the gotchas?
So the gotchas are like, first of all, like, yeah, you should know a bit of Unity, a bit of OpenGL if you're using it. Because when I was upgrading this app from my Nexus 5 to the 6P, because the drivers of OpenGL were slightly different, I didn't see like shaders, for instance, because the shader runtime was like different. So yeah, this is a lot of things you have to do manually, right? So you should test it on all of the devices, even on the toaster. But yeah, so there's a lot of manual labor involved, which hopefully is not the case if you're using Unity or if you're using another library, right? So
Do you recommend any libraries?
I have not played around with a lot of other libraries, so I cannot. I hope I didn't scare you away from OpenGL, but I'm sorry.
Thanks a lot.
Yeah, thank you guys.